Let's take a look at another example of determination of azimuth, giving a known azimuth or bearing, and then angles turned to the right. So what we have here is a compute azimuths of all the lines for a closed traverse, A, B, C, D, E, back to A, that has the following balanced angles to the right using the directions listed below. Now, here's the thing, is when you're looking at angles that are listed like FAB, ABC, the letter in the middle between the beginning and the end is the vertex angle. So that's the actual angle at which those values are listed. So basically we know we have to look at if we have a balanced system. So it says that it's balanced, but like I said, I like to check. So there's six angles. 6 minus 2, 4 times 180 is going to be 720. When I add up all the angles, it does equal 720. Always do this as a check. So I sketch the problem. So I have a bearing of north 33 degrees, 46 minutes, and 25 seconds east. So A to B has a northeast bearing. Now, when I start to draw FAB, there's where the 118 degree angle is. ABC, there's where the 123 degree angle is. And it goes all the way around. So make sure you go ahead and draw yourself a sketch, because I can already see, just by visually seeing, that B to C is going to be in the northwest quadrant, and it's going to be a little, less than 360, but a little more than 270. By drawing these pictures, you'll have a better understanding of what the azimuths and bearings should be at the end. So let's get started. So the first thing is, we know our bearing is 33 degrees, north 33 degrees, 46 minutes, 25 seconds east. But we have to convert that to an azimuth. Well, lucky for us, it is the bearing is the same angle as the azimuth angle. So we just have to change it to the azimuth. Now, remember the process. Azimuth, back azimuth, add an angle. We get a new azimuth. So we started with the azimuth, we add 180 because our initial azimuth is less than 180, and we get the back azimuth. So from B to A, it's got a back azimuth of 213. I add the angle of 123 degrees at B, and that gives me my new azimuth from B to C. So B to C, like I said, was about 337. And now I'm going to have azimuth. I need my back azimuth. Have to subtract 180 because the azimuth is greater than 180, and that gives me my back azimuth from C to B, which makes sense. If I look at this angle here, it's about 157 degrees. So now I add the angle at C, and I get 104. So my azimuth from C to D, just looking at it, I'm going all the way around. It's not quite 270, so yeah, it's 261 degrees. So that's my azimuth from C to E, azimuth. Get my back azimuth. Notice I subtract 180 because it's greater, the original azimuth is greater than 180. And I get my azimuth from D to C, my back azimuth of 81 degrees. I add my angle at D, the 133, and I get my new azimuth from D to E. So D to E is 215. So I subtract 180 to get my back azimuth from E to D, and then I add my angle at E. That gives me my azimuth from E to F, which is 143 degrees. So I have to add 180 to get my back azimuth from F to E. All the while checking with this that your azimuths make sense with your picture. Okay? So you can draw the picture in AutoCAD and make your life a little bit easier. So I've got my back azimuth, F to E. I'm going to add my angle at F, and I get an azimuth from F to A. But when I add that angle, notice 455. In survey, like I said, we don't use angles greater than 360. So I'm going to subtract the 360, and that's going to give me my azimuth from F to A of 95 degrees. I have azimuth. I got to get my back azimuth, A to F. So I add 180 because the original azimuth was less than 180, and I get my azimuth A to F of 275, which it looks about 275. And then I'm going to add my angle at A. Now this is my closing angle, so when I get the angle, it should be the same as the original angle I started with, 33 degrees, 46 minutes, and 25 seconds. it's actually 393. Actually, in realistic, this 393 is the exact same value as that. It's just a rotation. So I subtract 360 and I do get the 33 degrees, 46 minutes, and 25 seconds. Now, the second part of the problem says, what is the bearings of all of my azimuths going clockwise? A, B, C, D, E, and F. Back to A. So the first one, the azimuth was in the northeast quadrant, so it's going to be the same as the bearing, but I'm going to put north and east on it. Now, it's not all azimuth, not all traverses are always going to start in the northeast, so be aware of that. It could have come off to the southeast, and it's the same process. It's just your very first azimuth is different. So my azimuth from B to C is 337, so that tells me I'm in the fourth quadrant or the northwest quadrant, and I have to take 360 minus the azimuth. And I can see that it's this little angle here is 22 degrees, 53 minutes, and 7 seconds, but it's going northwest. Always remember northwest. A bearing always has to have those letters on it. The azimuth C to D, I can see is going southwest. And since the angle is 261, I know I'm in the southwest quadrant, so I have to subtract 180 from the azimuth, and that's going to give me a south 81 degrees, 17 minutes, 25 seconds west. The azimuth from D to E, I'm again going southwest, so I take the azimuth and I subtract 180 from it, and it's going to give me south 35 degrees, 10 minutes, and 15 seconds west. You can just plug these into your calculators. I'm just explaining so you can see the pattern. E to F, I can see that it's going in the southeast quadrant, so I'm going to take 180 minus the azimuth of the 143 degrees. And that's going to give me a south, that's this little angle in here, south 36 degrees, 27 minutes, and 47 seconds east. And then lastly, F to A had an azimuth of 95. Well, we've already gone past a little bit of the northeast. It's going in the southwest. So I'm going to take 180 degrees minus the 95 degrees, and I'm going to get a southeast angle of 84 degrees, 40 minutes, and 34 seconds. So that's this big angle in here, always measuring off the south or the north line. All right? So we'll be talking about latitudes and departures next.